Hi class, so today we'll be studying how to solve exponential and logarithmic equations. So in the past couple lectures we've gone over how to study, we've gone over properties of exponents and properties of the logarithm. But today we're going to combine all that together and we're going to study how to actually solve equations that involve variables like x and y and logarithms and exponents. So to get started, I'll just remind you of what the exponent rules are and the logarithmic rules are. So first, our exponent rules. So the first exponent rule is that if you have x that is raised to the nth power and is multiplied times x that is raised to the mth power, what happens is that when these are multiplied together, the exponents are added. So this is equal to x times n plus x raised to the n plus mth power. So something like that. The second rule is going to be that when you have a quotient that involves x and its powers, say you have x to the nth, and you're dividing by x to the m, you can simplify this and write as just one power as x to the n minus m. Then the third rule that we talked about is that you can take, if you have x to the nth power in parentheses, and you want to raise it up to the nth power, so inside the parentheses is x to the n, and then you have parentheses, and the parentheses are raised to the m. What happens is that these exponents are multiplied together. So this is equal to x to the n times n. Alright, so these are our three exponent rules that govern what we're allowed and not allowed to do concerning expressions that have numbers raised to a power. So now I will remind us of the log rules. So remember that a log base b of x equals y. We write this, log b of x equals y. This means that y to the x power equals, b to the y power equals x. Right, so this is another way, when we have a logarithm, it's another way of writing an exponent. So log base b of x equals y means that b to the y power equals x. So this is sort of like you're looking for y, that when you raise the base to the y power, you get x out of it. So that's how the logarithms work. That's how they're defined. And we also went over three log rules that are useful to us. So our log rules are, first, if you have a logarithm that has x times y on the inside, you can break this logarithm up and you can say that this is equal to log of x plus log of y. So that's useful. The second property is that if you have a logarithm and it is a quotient, so you have log of x divided by y, you can also split this up. So remember that it is subtraction this time, so it's log of x minus log of y. And then the third property is that if you have a log, and on the inside we have log of x raised to the a power, right? This can be rewritten as a times log of x. So you can take the exponent is inside the log, you can take the exponent out and move it out in front, and you have a times log of x. So that's the three log rules. So these rules, the exponent rules and the log rules, will be useful for us as we start trying to solve exponential and logarithmic equations. So just to give you some intuition, let's assume that the first property is true. So let's assume that anytime we have log of x times y, we can write it as log of x plus log of y. It follows from the definition of the log, but we'll just assume that we can do it. I want to show us why property 3 holds. So let's start out with log of x to the a power. What is x to the a? Well, x to the a is just x times x times x times x over and over again until you get to a times. So this is just equal to log of x times x, x times x times x, all the way repeated until you get a times. Well, if you use property 1, which says that if you have two things multiplied together in a log over and over again on this, you can split it up, right? So you can say this is equal to log of x plus log of x plus log of x, however many times until you have a of them. So you have a logs of x's right here. I don't know how you'd say that. What is the plural of logs? I don't know. But this is just like saying 2 plus 2 plus 2 plus 2 plus 2 however many times, right? And it's similar to multiplication, because multiplication is just adding the same thing a bunch of different times. So this is the same thing as a times log of x. So yeah, that's sort of a proof, if you will, of the third property. So that gives us a little property with working with the variables and working with our log rules a little bit. So that's a little bit of practice. So now we'll jump into actually solving the exponential and logarithmic equations. So I'll erase everything. And we'll start with the exponential equations. So a typical exponential equation involves some base, and a base is raised to the power, but inside the power you have a variable. So in this problem you'll see that there's a variable that's inside a power, which is maybe not something we're so used to dealing with. So in this example we're going to solve for x. And the equation that we're given is 7 to the x power equals 9. So this may be unlike most algebraic equations, because in algebraic equations you might have 7 times x equals 9. And the way that you would solve 7 times x equals 9, you divide both sides by 7, right? And you get x equals 9 divided by 7. But you can't really do that here. You can't divide by 7. That doesn't help you any. How do you isolate the x? And so the way that you do that was with logarithms. You might think of one particular property of logarithms that we could use here to get the x out by itself. And if you're thinking about a property that lets you move the exponent out in front, log property 3, you're thinking of the right property. So with an equation, you're allowed to take the log of both sides. So it doesn't matter which base you choose, because all logs of every base have property 3. So most calculators have an ln button, so I'll just choose the natural log, ln. So you can do that to both sides. So you get the natural log of 7 to the x power equals the natural log of 9. We can use property 3 of logarithms to rewrite this as bringing the x out in front, x times natural log of 7 equals the natural log of 9. Now, log of 7 is just a number, natural log of 9 is just a number, and x is a variable. So you can divide both sides by something to solve x, right? So if we divide both sides by log of 7, we get we get the answer, right? So this finally implies that x equals the natural log of 9 divided by the natural log of 7. And you can take that in your calculator and you can punch this in and you'll get a number. But as far as I'm concerned, this is true. This is what you need. So yeah, it might be weird not having 2 or 3 or decimal places or 7.24, but this is a number. This is the answer. So we'll do another one. Another exponential equation. So in this equation, the instructions are solve for y, and we get, hey, I'm recording myself, so you can sit in here, whatever. Okay. So we're going to solve for y, and solve for y in 2 to the 4y plus 1 minus 3 to the y equals 0. So in this situation, we have, we can't immediately just take the logarithm of both sides, so because that won't help us any. So the first step is going to be to move this 3y to the other side, so we can take a logarithm. So we have 2 to the 4y plus 1 equals, adding 3 to the other side, 3 to the y power. So at this point, we can go ahead and take the log and move our powers out in front using that special property of logs. So doing that, we get that natural log of 2 to the 4y plus 1 equals the natural log of 3 to the y. So when you have a base to a power inside a log, you can move the exponent out in front. So we get that 4y plus 1 times log of 2 is all that's left in here, equals y times natural log of 3. So now we have to solve this equation for y, but we have y sort of in both sides of the equation. So what we want to do here is we want to move all the y's to one side and all the numbers and everything else to the other side. So we need to distribute this term that's on the left-hand side first. So we multiply each term by log of 2 to give us 4y times log 2 plus log of 2 equals, we'll just leave the right side the same, y times log of 3. Now since we're moving all the y's to one side and all the numbers and everything else to the other side, I'll move the y log 3 to the left and then the log of 2 to the right side. So we get that 4y natural log of 2 minus y times the natural log of 3 equals negative natural log of 2. So I have a y in the first term and a y in the second term, so we can factor out a y. When we do that, we get that 4 times log 2 minus log 3 times y. So we factored out the y's and we left everything that was remaining besides the y. And then that equals negative log of 2. So finally we have 4 log 2 minus log 3. That is just a number. We have y. That's the variable that we're solving for. And we have negative log 2. And that's just a number. So we can divide both sides by 4 times log 2 minus ln 3, everything that's in parentheses here, and we get the answer for y. So finally, y equals so y is negative log 2 over 4 log 2 minus 3. That's how you solve exponential equations.